To convert a DXF into G-code, click on Options, then click on Job Options. In the Material tab, we want to specify the size of material that we'll be working with. In this case, it's going to be 48 by 48 inches. In the origin layout, make sure that the bottom left is checked. Thickness of material should be 0. Rapid clearance should be 1. This will prevent an error in the post-processor from happening later. Height of bottom of material above table, 0. Plunge safety clearance, 0. If you want to, you can save this material for later use, and then you can load it. Click OK. Now we need to load the DXF. Come up to File, click on Import Drawing, locate the DXF that you want to load. You can double click on it or click on Open. Make sure scaling is set to inches. Drawing position, lower left. Click OK. Now we have the part on the material, but the part is right on the edge of the material. This will create an error later when we create or generate a tool path. Come up to the top and click on the nesting tool. Once the part is highlighted, you can click on it and drag it out away from the edge of the material. Now that we have the part away from the edge of the material, we can create layers. We need an inside layer and we need an outside layer. This is for direction of cut. Click on the contour tool. Hold the control button down at the same time that you left click to select the contour. Do this for all the internal contours. Now right click, click Move to Layer, click New Layer. We're going to call this Inside. Now hold the control button, left click, right click, Move to Layer, New Layer. We're going to call this one Outside. Now we've successfully created 2 layers. To check the layers, we can uncheck it to only see the layer that we want to see. In this case, we're looking at the internal contours. In this case, we're looking at the external contours. Now we need to create a tool. Click on the jet cutting tool icon. Make sure that plasma gets selected. A tool number will be automatically assigned. The kerf width can be found in the plasma operation manual in the cutting chart or cut process that you've selected. It's a good idea to set the feed rate to a default of 100. You can specify exactly what you want the feed rate to be later once you've dialed it in. Pierce delay, pierce height, plunge rate, cut height, and pause at end of cut should all be set to 0. Make sure that lead type is set to normal. Don't use ramp or wiggle. Click on OK. Now we're ready to create operations. We'll need 2 operations, one for the internal cuts and one for the external cuts. This corresponds to the layers that we just created. Click on the operation tool. The first operation that you want to do is the inside cut. So under contour method, select inside offset. Under layer, select the inside layer. You'll also need to select the tool that you want to use. This is the tool that we just created. Feed rate, default this to 100 unless you know exactly what it should be. Use reverse cut direction for hypertherm and thermodynamics. You can also specify a lead in and a lead out. Our internal contours are going to drop out, so it's not logical to set a lead out. All we need is a lead in. So we're going to click on arc. At the bottom you can specify the lengths of the lead ins and lead outs. It's a good idea to specify a length of a lead in that corresponds to the thickness of the material. Now click on OK. You can see our first operation appears, and we do have a kerf compensated toolpath appearing on the screen. The blue lines are rapids or traverses. This means that the torch will not be cutting, it will simply be moving to the next segment that it will cut. The green is the toolpath. You can see that there's yellow letters that specify the start points. Now we need to create a toolpath for the outside. Click on the toolpath icon again. Select outside offset. Under layer, choose outside layer. We're going to use the same tool. I'm going to default feed rate to 100. Make sure that reverse cut direction is checked for hypertherm and thermodynamics. And in this case, we could do both a lead in and a lead out since this is an external contour. So I'm going to go ahead and select arc. I'm going to change this to 1/4 inch. Click OK. Now we have both toolpaths. I do notice that at the bottom, these lead-ins are extremely close to the edge of the material. So what I'm going to do, just for safety, is move the part out just a little bit more. Now I'm going to click on the post-processing button in the upper left. I'm going to select the location that I want to put the G-code that I'm getting ready to create and click Save. You get the running post-processor window. It tells you that post-processing is complete. You can click OK and we're done. Sometimes you'll get errors that will appear up here in the left next to the parts window. These errors are letting you know that there's something wrong with your operation, your tool, your layer, or your part. You'll have to clear the error before you can post-process. Post-processing with an error can create unpredictable results.